All right, everyone, here we are at 17.3, day number 1 notes. You can see up here in the top right portion of my slide that I have a couple of convert to complex polar form. I'm going to see if you can think of this as swiftly as I can. I see a 45, 45, 90 triangle, do you? Right 3, down 3? I see a modulus of 3 root 2. I see an angle in the 4th quadrant at negative pi over 4. Okay? And the glasses do it. Okay, is there any difference between the first one and the second one? Yes, but no difference on with regards to the modulus. It'll still be 3 root 2, but now what will the angle be? There we go. 3 pi over 4. I'm going to introduce you to our friend DeMoivres. Yeah. DeMoivre's formula. You ready? My name, DeMoivre. Okay, here is DeMoivre's theorem. Okay. Let's say Z, quiet please, let's say Z equals R cis theta. Let's say that W equals, I don't know, let's come up with a different letter. How about M cis beta? Okay. Yeah, oh yeah, we're getting crazy here. If I took Z times W, I'm going to do the proof of this in a moment. I'm going to have another cis number, right? I'm going to have another complex number in polar form. However, what I'm going to do is I'm going to take the 2 modulus and I'm going to multiply them. Makes sense, right? Do you remember with logs, when we multiply, what do we do with the exponents? You add them. So when we multiply 2 complex numbers, we add the angles. I'm going to prove it to you in a couple of minutes. What do you think happens when we take Z divided by W? We take R and M and do what with them? Divide them. What do you think we do with the angles? Yeah, we subtract them. Okay, this is our friend DeMoivres. DeMoivres. Okay, so what do you think happens here? If I take Z to the 3rd power, would you agree that that's this? Yeah, right? Well, DeMoivres says that that would be this. We would take whatever our modulus is to that power, but we would multiply our angle by 3. Okay. All right, here we go. So we got the product rule, which we covered on the last page. We got the power rule. We got the quotient rule. So I'm going to prove the product rule. Okay, so Z cis alpha. Well, Z cis alpha is really Z times cosine alpha plus Z times I sine alpha. That's just the definition of what cis means, right? I'm going to do the same thing here for W. So this would be W cosine of beta plus Wi sine of beta. So what I want in the end is I want to come out with this. Right, that's where I want to end up. You with me? Okay. So what do I got to do with this thing? I got to multiply them, which means I have to use a 4-lettered F word called FOIL. Ooh. Okay, so I'm going to FOIL. Here we go. First, Well, that'd be z cosine alpha times w cosine beta. Okay, so z times w cosine of alpha cosine of beta, right? Sorry, I might have said something wrong there. With me? Just watch. If you're writing this, you're hurting your brain. Just watch this. Now I'm going to do outside. So I will have plus z times w cosine alpha I sine beta. Okay, inside I will get plus z w I sine alpha cosine beta. And if I do last here, what will I get? Plus what? zw I to what power? Squared sine alpha sine beta. Woo! So that was first, that was outside, that was inside, that was last. Okay, so let's look at this for a moment. What do all of these have in common? ZW. Okay, so I'm going to pull all of those out, right? Oh, look at that. I have ZW. Ciao. Okay, now some of them have I's and some of them don't. So let's go with the ones that don't have I's. Where are they? Well, that'd be this. That'd be cosine alpha cosine beta. And the other one that doesn't have any I's involved, well, the rest of them do.
Well, technically alpha.
Ah.
The last one doesn't.
What is that?
Therefore, it's
negative 1. Do you see Coco CC?
Yeah.
Okay, now the ones that do have I's, right, I'm going to say plus I. I'm pulling an I out of there. What would the rest of that be? Well, if I pull an I out of here, I have cosine alpha sine beta. If I pull an I out of there, I have sine alpha cosine beta. So how about this? Cosine, oops, I want to write it the other way. I'm going to put this one first. Sine alpha cosine beta plus sine beta. Do you see Sports Center, Sports Center? Cosine alpha. So how could I rewrite this? Cosine of what? Alpha plus beta. Oh, yeah. And how could I write this? Oh, that was good. Plus I sine of alpha plus beta. So if I have z times w times that, by definition of cis, so if you're multiplying two complex numbers in cis form, you multiply the coefficients, you add the angles. Right? There's your proof. Okay, we could do the same thing for quotient, but I'm not going to do it. Okay, but it would come out where you'd have minus. All right. All right. On the next page, we're going to employ these. We're going to employ our new skills. Z times W. Who in the world wants to do this, right? Do you want to FOIL this? No, neither do I. That's why I'd write each of them in cis form first. Right? I'd write each of them in cis form. So let's write Z in cis form. What would it be? Well, I got to draw a triangle. So that'd be in quadrant 1, right? 2 root 3 and 2. So that's 2 root 3. That's 2. Anybody with me that they're already seeing a 4 right there? Yeah. And this angle right here is pi over 6. Anybody? Yeah. So Z equals 4 cis pi over 6. Okay, W. W, draw a triangle. Okay, so that's in quadrant 2. Chow, chow. So over 1 up root 3, I'm seeing, what would that be, a 2 there? And this angle would be pi over 3. Therefore, this would be root 3 cis 2 pi over 3. Right? To get from the positive real axis to there, I'd have to go 2 pi over 3. Okay, so z times w. Oh, my bad, my bad. Yeah, my bad. That should be a 2. Thank you. See, the brain farts once in a while. Okay, so if I multiply z and w, what do I do with the 4 and the 2? Yeah, I get an 8. What do I do with pi over 6 and 2 pi over 3? Yeah, so I got pi over 6 plus 2 pi over 3. That means I got to have a common denominator, which I think this would come out to be 8 cis 5 pi over 6. There you go. That's z times w. You multiply the modulus from each, and then you add the angles. Well, okay, so let's take w, which I put a z there. That should be a w. Let's take w to the 5th power. So that'd be 2 cis 2 pi over 3 to the 5th power. Well, that becomes 2 to the 5th cis 5 times 2 pi over 3. Right? Remember, we multiply the angle by the exponent, but we take the coefficient out in front to that power. So, there you go. Could you reduce that if you wanted to? Sure. Sure you could. Okay. What would 10 pi over 3 be? Would it be equivalent? No, it'd be equivalent to 4 pi over 3, I think. Because 6 pi over 3 is 2 pi. Right? So then it'd go another 4 to get to 10. So an equivalent version of this would be 4 pi over 3. Yeah, either of those would work. Or negative 2 pi over 3, wherever you want to go with that. Okay, so now we take z and we divide by w. Well, z is 4 cis pi over 6. And w is 2 cis 2 pi over 3. Well, yeah, 4 divided by 2 is 2, but we got to do a little work here. Pi over 6 minus 2 pi over 3. I think that's negative pi over 2. Right? So this would be a 4 pi over 6, which would make this negative 3 pi over 6, which would be acceptable, and then reduce. I mean, today's lesson is pretty straightforward, right? You just got to make sure you know the rules. And then I do take equivalent versions of any. Okay, chow. Problem 51. Let's first put z into cis form. So I have to draw a triangle. Which quadrant? Second. Good. Okay, so I go left, negative 3 root 3 over, oh, that was a root 2. Wow, what the heck? Negative 3 root 3 over 2. That 2 disappeared. Up 3 over 2. I'm seeing this angle to be 5 pi over 6. You may or may not. I don't know. The hypotenuse is going to be 3. Some of you are just crushing right now. Some of you are like, draw me another triangle. I will. A known triangle. How about this? Negative root 3 over 2. And this? 1/2. How do I get from 1/2 to 3/2? I multiply it by 3. Boom. I'm there, right? So I've just scaled it by a factor of 3. So the hypotenuse here is 3 cis angle 5 pi over 6. Chomp. W. Oh, that's pleasant. Do you see a 45, 45, 90 triangle? I do too. Let's figure out the hypotenuse. 3 root 2, negative 3 root 2. I'm seeing a 6. Are you? How did I do that so quick? Yeah. All right. Oh, you draw another triangle, Mr. Ludd. I want another one. Okay. Fine. 1. Ready? What do we say these are? Root 2 over 2. Negative root 2 over 2. Yeah? So you could take either of these, right? So let's say we want to take root 2 over 2, multiply it by something to get 3 root 2. Well, I would multiply both sides by 2, right? Are you with me? Yeah, and then divide both sides by root 2. The root 2's go away. What's 3 times 2? 6, right? 6. Okay. I'm just looking at similar triangles. So this would be 6 cis negative pi over 4. 6 cis negative pi over 4. You could do 7 pi over 4 if you want. That's fine. Okay, so w squared over z cubed. W squared. Well, that to me, w squared will be 36 cis. What do I do with the 2? Multiply it. So I get negative pi over 2. Right? And z cubed would equal 27, right? 3 to the 3rd power. Cis. I'm going to reduce. If I multiply this by 3, what would happen? I get 10. Right? Oh, never mind. I get 5 pi over 2. Agreed? That's equivalent to 5 pi over 2. That'd be equivalent to 5 pi over 2. Okay. So I could leave this as pi over 2. So then now I do division. 5 pi over 2? Yep, you go 1 extra. So then if I divide 36 and 27, I get 4/3. 9 goes into both of those. Cis minus what? Chow. Could you write this? Yeah, that'd be acceptable too. Okay. Why would you do that? Because pi and negative pi are coterminal. Like, subscribe, comment below. $13 to GNC for the 100th sub. We're at 65 right now. Make 35 fake emails tonight and get yourself $13. That's like 2 protein waters and a protein bar. Goodbye.